So, 5.2, medians and altitudes. Right, remember on the special segments, again, we talked about these being two different types of special segments of our triangles. So the first one we're going to talk about today is medians. And remember, a median is where you go from the vertex to the midpoint of the opposite side. All right, and we know it's the midpoint because this side is divided into two congruent parts. All right, so if we look at the median of another vertex, it's just going to go through, okay? And then today we're specifically going to be talking about that center point, okay? So leading into today's terminology, all right, the centroid theorem, new vocab word, okay? The centroid is just the point of concurrency of the medians of your triangle, or basically where all of the medians intersect. Okay, so in this example, it would be point P. Okay, so all of our medians intersect at the centroid, and the centroid has a special little rule to it, all right? That's why there's a whole theorem for it. It says that the centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. So basically all that means, if we're looking at our vertex B, the distance from the vertex to the centroid is 2/3 the distance of our whole median, okay? So again, from the vertex to the centroid is 2/3, 2/3, okay? So what that looks like in an example, if we have triangle ABC, and we're told Q is our centroid, and then they tell us also that BE, this entire median, is 9, okay? So we're asked to find BQ and QE, okay? So how to do that? Remember, according to our theorem, the distance from the vertex to the centroid, in this case BQ, equals 2/3 of our entire segment. So let's write that down. BQ equals 2/3 of our entire segment, which is BE. Okay? So in order to solve for BQ, we need to plug in the value for BE, which they tell us is 9. Okay? So again, we're just plugging in the information we know. Now the last step is to just solve. Okay, so BQ equals 2/3 times 9 is 6. Okay, if it's hard to look at it straight ahead, you can do 2/3 times 9 over 1. All right, there are two ways. I'll just go straight across. 18 over 3 is 6. Okay, so we determined that BQ is 6. Okay, so we'll put that right here. The pink line is 6. Now we need to find QE, what's left over. Okay, so in order to find that, there are, again, multiple ways to do it, but for today's purpose, we're going to say, okay, I don't know what QE is, but I know that QE plus BQ equals my entire median, okay? So let's write that down. QE, my green line that I'm solving for, plus BQ, which we just solved for, equals BE, okay? So, let's substitute for what we know. QE is what we're solving for. We just determined that BQ is 6 and BE is still 9, okay? So to solve for, how did I get this? Okay, so we've substituted in for the values that we know, and then the last thing to do is solve for QE, all right? So QE, let's probably put this up here so it's not in the green. QE equals, if we subtract 6 from both sides, we're going to be left with a total of 3. Okay? So QE is 3. Right? So what do you guys notice about these two numbers? Right, so the long segment is 6 and the short segment is 3. There's actually a reason behind this. Okay, maybe you'll see it in the next example. Okay, all right, so next example, JKL. So JKL. We're told that PT is 2. So this right here is 2. We want to find the length of KP. All right, this long portion here. Okay, remember our theorem states that the distance from the vertex to the centroid, in this case P, is going to be 2/3 times the full distance. Okay, so we'll say our full distance here, KT, is purple. KT equals the full length. All right? We don't know what KT is yet, but we're going to figure it out. Okay? We're going to solve for what we need to solve for. Okay? So KP, again, according to my theorem, equals 2/3 times KT, or my entire median. Okay? So, I don't know what KT is. The last example, we had the full median length, but here, we don't have that. Remember what we did last time? Oops, where'd it go? Okay, so looking back up here, we said the short portion plus the large portion equals the full median, right? We can do the same thing down here. Okay, so we have KP, what we're solving for, equals 2/3, again, straight from my formula, times KP plus PT. All right, and again, the reason I'm doing that, KP plus PT is this full median right here, KP and PT. So we're just substituting in the values that we know, right? So now that we're here, hey, we're given the length of PT. So it's going to make life a little easier. Okay, so simplify it out and plug in for what we know. So 2/3, again, KP. But now we're going to plug in the value of 2 because we're told that PT equals 2. So plug that in. Okay, now all that's left to do is distribute. So we are going to distribute 2/3 to both. It's going to leave us with KP equals 2/3 KP, and then 2/3 times a positive 2 is a positive, just kidding, 4/3. There we go. All right, so all I did was distribute my fraction to both values. Okay, now we need to get our KP on the same side. Okay, because we are solving for that missing side. Right? So I'm going to subtract. That's going to leave me with 1/3 of the length equaling a total of 4/3. Okay? Now that we're here, remember we're solving for just the side, so we need to get rid of this fraction. So I'm going to multiply by my reciprocal. Okay? The 3's cancel out. And then that leaves me with KP equaling a total of, again, our reciprocal cancels out our denominator, 4. So KP equals 4. All right. So now we're going to continue on. All right, so medians and altitudes on the coordinate plane. So for the purpose of this problem, it asks us to use the coordinate plane. However, there's an easier way to do it. Okay, so we're going to work with the formula that we know, right? In the book, it doesn't show it right here, but the formula is the same thing that we would do if we were working in the coordinate plane. So what's happening, we have a performance artist, she's wanting to balance these triangular plates on the sticks, okay? If anybody's tried balancing anything, you know you have to get your balance point right in the sweet spot, right there in the middle, right? So there's a term for that. That's called the centroid, okay? It's the centermost midpoint, okay? Where all of your midpoints come together. It's going to be the most balanced, okay? So we want to find the midpoint location of this coordinate. In order to do that, we need to use our x values and y values, okay? So this 0 sub x is going to be the centroid location of our x value, and this will be the centroid location of our y value, okay? So what we do, we're going to color coordinate this because you guys know I love color. I'm going to say my centroid x value is going to be this x, and this x added together. So 1, 5, and 9, okay? And then according to our formula, we have to divide by 3. So 1 plus 5 plus 9 is 15 over 3. So we know that our x value of our centroid is 5. Okay? Now we're going to say, all right, what's my y value? Same thing as before. Use the coordinates given and the formula provided. So we have 10, 0, and 5 divided by 3. I promise I didn't plan it, but it just so happens my y value is 5 as well. Okay? So the centroid coordinate is 5, 5. Right? So if we were to graph it, it'd be right about here. Okay? Which looks kind of accurate, right? Also, I'm no artist myself, so it's not perfect. Okay? But using your centroid formula will give you that exact coordinate. Okay? One last thing, and then we will be done with the notes today. Okay? So for altitudes, the second part, remember, the altitude is going to be the height of our triangle. So we go from the vertex to the opposite side, just like we did for the median, but the difference is your altitude is perpendicular. Okay? So again, there are 3 sides, so 3 altitudes. There you go. So the point where they all intersect is known as our orthocenter, okay? New vocab word. So the orthocenter is where all of your altitudes intersect, okay? Point P, all right? Remember, the difference between an altitude and the median is your altitude is perpendicular. Your median cuts the side in half. So in order to find the altitude intersection point, or your orthocenter, here's an example of a coordinate plane. Okay, so I have some of these steps written out already just to help guide us where we have to go, but this is the idea of what we have to do. We have a triangle on the coordinate plane, okay? We need to find the intersection point. So I'm going to say for my first triangle, I'm going to do point F, okay, and I need to find the distance or the equation of this altitude here. Right, this altitude is intersecting line GH, okay? So to find the intersection of, or the equation of F, we need to find the slope of GH in order to write equation for altitude F. Okay? So, it's a few steps, but it's all things that you guys have done before. So, first step, find the slope of GH. How do we do that? We use our slope formula. So I'm going to use y1, y2, okay? So I have y2 minus y1 over x2 minus x1, okay? When I simplify this out, I get negative 6 over negative 3, or a positive 2. So now I know my slope of GH right here is 2. But remember, we need to find the slope for the perpendicular line because our altitude is perpendicular. Does anyone remember how to find the slope of a perpendicular line? Yes, awesome. Opposite reciprocal. So opposite would be a negative. All right, so the slope, we'll do it pink. So the slope would be opposite, negative, reciprocal is 1/2. Very good. So now that we know our reciprocal, or our new slope, we can plug that into point slope form, okay? Because remember, when we're given a point, in this case f, and the slope, we just determined is negative 1/2, we can write the equation of the line, okay? So we're going to say y minus our y value of 4, okay, equals, our slope is negative 1/2, x minus a negative 2. So again, I changed that to a positive because our x value is negative. All right, now I just need to distribute. That leaves me with y minus 4 equals negative 1/2 x minus 1. Okay? And then now our last step, the altitude of f, or the equation for that line, is y equals negative 1/2 x plus 3. Okay? So this is going to come in handy when we find that intersection point. So just like we did for the altitude for f, we need to find the altitude of g. So the altitude starts at our vertex G and it extends to the side FH, okay? So just like we did for our first problem, where we found that equation of the line, we need to do this again for our new altitude. So in order to do that, we're going to find the slope, we're going to shorthand this a little bit, of FH, so we can find the slope of altitude G. Okay. Oh boy. Oops. Okay. So the slope of FH, again, we need to use our slope formula. So y2 minus y1 over x2 minus x1. All right. FH we see is here and here. Use those coordinates. We have negative 2 minus 4 and 1 minus a negative 2, which becomes a positive. Okay, so negative 6 over 3. Negative 2. Okay. So now that we have our initial slope, we need to find the perpendicular slope. Okay. Perpendicular slope, which is opposite reciprocal, or 1/2. Okay? So we plug this information in now. Right? Y minus our y1 is 4, because we're using point G, equals 1/2, my new slope, x minus 4. Right? So just like we did before, simplify it out. We get y minus 4 is 1/2 x minus 2. Right? Again, this is stuff you guys have all done before. I know it's a lot. Right. And then last step, the altitude equation of G is y equals 1/2 x plus 2. So now we have the equations of our two lines. We need to find the intersection point. Let's do it by hand. No, I'm just kidding. There's an easier way. Okay, so what we're going to do, we're going to, step 3, find the intersection of altitude G and altitude F. So once we've graphed it in Desmos, we determine that our intersection point is at 1, 2 and a half. Or we can write it as 1, 5/2. All right, and remember, for the graphing calculator, use desmos.com or click the link at the top of our Schoology page. Okay?